I'm going to show you one more time how to multiply fractions. This time we'll concentrate on what's going on when you do the canceling. This video will be good for you to watch if you're having trouble reducing the fractions all the way, or if you would like to know more information about why canceling works and how it works. The problem we'll do this time is 42 divided by 55, 42 over 55, times 35 over 54. So we'll multiply these together and we'll use the canceling technique. In the process of demonstrating this problem, I will demonstrate a little bit more carefully how canceling works and what's going on. When you cancel, you're really dependent on your multiplication tables. And if you know your multiplication tables well, then you know that 6 times 7 is 42, and 6 times 9 is 54. So when we cancel, we are thinking about 42 as being 6 times 7, even though we don't always write it that way. And we are thinking about 54 as being 6 times 9. The other direction is a little easier. 55 is 5 times 11. And 35 is 5 times 7. If you know your multiplication tables well, you have that. Now, the canceling process happens whenever you see the 6 here and the 6 on the other diagonal, across from this one on the diagonal, and those 6's cancel out. 6 divided by 6 is 1. When we divide those numbers by 6, we're left with 7 up here and 9 down here. The other direction, we divide the 35, which is 5 times 7, by 5, leaving the 7. And we divide the 55, which is 5 times 11, by 5, leaving the 11. So when we do the canceling, we are scratching out like factors from numerators and denominators. And we multiply what's left. 7 times 7 is 49 over 11 times 9, which is 99. So the reduced fraction is 49 over 99. Now another way to do this, especially if you do not know your multiplication tables well, and especially if you keep missing multiplication problems on the arithmetic test because they're not reduced all the way, would be to write the problems in their prime factorization. So here's the problem again, looking at it slightly different. I will take the 42 and I will find the prime factorization of 42. Remember, that looks like this. 42 equals, we think of anything that we can that goes into 42. We make a factor tree. It looks to me like 2 goes into 42. If you think of 7, that's okay. Your factor tree might look different from mine. At the end, we'll both have the same answer. I'm thinking 42 is divisible by 2. 2 times 21, in fact. Now, 2 is prime, so I circle that. 21 is divisible by 3. So 3 times 7 is 21. So this way you get to use the easier multiplication tables. And 42 now, all these leaves, that's what we call the circled numbers. They're prime numbers. You're done when the circled numbers are prime. Those are the leaves. You multiply them together, 2 times 3 times 7, and that's the 42. This is your factor tree, and these are the leaves. The other 3 numbers need to be written in their prime factorizations. You have 55. Well, that's easy. 55 is divisible by 5 and 11. 5 and 11 are both prime, so you're done. 55 is 5 times 11. And the other numbers, 35 in the numerator, that's also easy. 35 is 5 times 7, and those are prime. 5 times 7. And the last number was 54. 54 has a few more factors. This will be a little bit longer. 54. Anything you can think of that goes into 54. Do you think of 9? 6 times 9 is 54. Do you think of 2? Maybe you think of 2 because 54 is even. So we divide 54 by 2. You have to do long division maybe, but 2 times 27 is 54. 2 is prime. 27 is 3 times 9. 3 is prime. 9 is 3 times 3. And those are prime. So 54 equals 2 times 3 times 3 times 3. Now that's a little bit of work. It's much better to know your multiplication tables very well so you can do it like I did here. 42 is 6 times 7, 55 is 5 times 11, 35 is 5 times 7, and 54 is 6 times 9. If you know those tables, then you're good. However, if you keep missing them because you're not good with your multiplication tables, or if you keep having answers that are not completely reduced, then try the factor tree method. You have 4 numbers written in their prime factorizations. Here's what we do with those. The problem was 42 over 55 times 35 over 54. Write these numbers in their prime factorizations. 42 was 2 times 3 times 7. 55 on the bottom was 5 times 11. The other fraction, 35 on top, was 5 times 7. And the fraction 54 on the bottom was 2 times 3 times 3 times 3. Now, you can easily see what to cancel. The 2's on the diagonal going this way match up and cancel. The 3's cancel. 1 3 from here and 1 from here. The 7 up there does not match anything down here, so it does not cancel. The other diagonal, you have a 5 that matches the 5 up there. Cancel those. And the 11 and the 7 do not match. This is a good time to point out, you do not ever cancel straight across. You only cancel up and down or diagonals. And you can only cancel in multiplication. Do not ever cancel in any other operation. Multiplication, 7 times 7 is 49 over 11 times 3 times 3. 3 times 3 is 9. 11 times 9 is 99. There's the answer we got a while ago. This time it took us a little longer because I demonstrated a procedure for you to use if you're not comfortable with your multiplication tables. But that shows how canceling works. Is a very good shortcut procedure for multiplying fractions.